Good morning, 7th grade. Hope everybody's doing well, staying safe. I miss every single one of you, and I wish I could see every single one of you in class right now. We just go outside on the playground and play a big game of kickball. But unfortunately, guys, it's just kind of a weird time of the year right now. So without further ado, let's get started with our new lesson today. So chapter 7, lesson 6, probability of compound events. If you remember from last week, we discussed compound events, guys, and you should be familiar with a compound event is an event where more than one thing is happening. So when you think about it, there's some common events that we talk about. Flipping a coin, and if you flip a coin and you say or maybe it's flipping a coin and rolling a dice. So it's really any combination of two or more things that are going on at one time. Let's get started. So number one here, problem number one. You win a prize if heads is flipped and blue is spun on a spinner. So your spinner, let's go ahead and let's draw our notes. We'll go ahead and let's create a spinner. Make a circle, almost like kind of the game Twister. A game Mr. Garrett has not played in a very long time. Alright, so there's your spinner. We'll say red, yellow, blue, and green. So you win if you can flip a coin. We'll say we're at the carnival, you win a prize if you flip a coin and it gets heads, and you spin this spinner and you land on blue. Now guys, the key here is you've got to do both. You got to do both. You can't just do one to get the prize. You've got to do both of these to get the prize. So automatically you should be thinking, hey, that's going to be kind of tough. You got to flip a coin and land on this spinner and get both of them to happen. So your odds probably are not very high. Now, as kind of a refresher to last class. Last class we looked at outcomes. And I want to kind of talk about, guys, the difference between what we did with outcomes and what we're doing today, which is probability. So let's go ahead and let's find, okay, how many outcomes are there in this compound event? A couple ways we could do it. I think I'm going to do the tree diagram. I think the tree diagram is a nice one to kind of get started with, especially because we're going to see that tree diagram reappear today. So if I were to flip a coin, I could go heads or tails. So I need to start with my first two options. From there, I could flip heads and then spin the spinner and land on red, yellow, green, or blue. So red, yellow, green, and blue. I could, I'm going to separate these a little bit, guys, so it's a little easier to see. I could flip that coin and land on tails, and after flipping on tails, get red, yellow, green, or blue. And remember, whenever we found how many outcomes, guys, all we did is we counted all these branches on our tree diagram. So how many outcomes are there? There's going to be 8 outcomes. When you count all those up, there's going to be 8 outcomes all in all. Okay, now I want to focus on probability because that's what we're looking at today. So with probability compared to outcome. Outcomes is how many possible results you could have. Probability looks at, okay, what's the percentage that that event actually happens? Okay, so with this event, let's go ahead and we're going to start out with a fraction. So I want to look at the probability of heads. And the probability of landing on heads is going to be equal to 1/2. Okay, then I'm going to take my 1/2
I want to find the probability of landing on blue on my spinner. Okay, again, I want to leave this as a fraction. So how many pieces total on my spinner is there? There's 4. So 4 is going to be my denominator. How many of them are blue? That's going to be 1. So that's kind of your refresher for how we got 1/4, how we got 1/2. Well, heads or tails, that's 2 options. Heads is just one of them. What I'm going to do from here, guys, I'm going to take my fractions and I'm going to multiply them. So I'm taking 1/2 times 1/4. And when I multiply these out, remember fractions, you multiply straight across, I'm going to get 1/8. And that is going to be my probability. So the probability of this happening is going to be a 1 in 8 chance of this happening. We can find the percentage, which I would like for you to do on each of these problems. We take 1 divided by 8. I get 0.125. So this is equal to 0.125. And if I turn that into percent, move my decimal 2 spots to the right. So my percent is going to be 12.5%. So it's not a very high percent of this happening. You're only going to be able to do this about 12.5%. So again, not very high chance of this happening. But this is how we find probability, guys. Probability, we're looking at a percentage. I'm finding the probability of my individual things and then just multiplying them together. So if you know how to multiply fractions, if you know how to find the probability of one thing happening, you can do these without a problem. All right, let's look at number 2. Let's take a look at number 2. So number 2, it's a little different, little same, little different. So this time you win a prize if the number 3 is rolled. And we'll just say it's on a standard 6-sided dice. So the number 3 is rolled and you land on red on a spinner. And I'm going to just borrow that same spinner that we just looked at from the previous problem. So go ahead and draw a circle. That's a lot better circle than my other one. Draw a circle, divide it into those 4 evenly sized pieces. And then again, red, yellow, blue, green. All right, so this time, again, I'm just looking for the probability here. Probability, my first event is a 3. Win a prize if number 3 is rolled. So the first thing that happens is this number 3 is rolled. So I'm going to find the probability of a 3. Write it as a fraction. There is 1 3 on a 6-sided dice. So of those 6 options on a dice, only one of them satisfies it. Then probability of red. I have 4 evenly sized pieces, only one of them is red, so 1 in 4 chance. And then again, take your 2 fractions, multiply them together. So then 1/6 times 1/4, multiply these across, you get 1/24. So the probability of this one happening is a 1 in 24 chance. And again, I could go through, find the percentage, which I want you to do on all of these. 0.0, so this one's going to be equal to 0.0416. Turn this into a percentage. Move your decimal 2 spots to the right, equal to 4.16%. So again, another low percentage here. Another low percentage. So 4.16%. Just to kind of clarify, guys, on how this works. So let's look back at number 1. Notice how we had 12.5%. Well, as a fraction, this was 1 out of 8. The way we can relate this to what we just did is because, guys, look, there's 8 different options here. There's 8 different outcomes. I want the one that's going to be heads and blue. There is only one outcome that results in heads and blue. There's not another one of them up here that is both heads and blue. So I only have one option out of 8 total. And hey, it matches up with my fraction. There's one option out of 8 total. So that's kind of why this makes sense in how it happens. So again, we can take that 1 out of 8 and then turn it into percent to find the probability of it happening. So this is why we found the outcomes last lesson and why we're transitioning into probability this time. And we could do the same thing on number 2 and create a tree diagram. It would have 24 different outcomes, 24 different branches, and only one of those branches would be both 3 and red. So again, that's just kind of another alternative to solving these. You don't have to multiply them out, but I think it's easiest by doing so. I also think, guys, it's easiest if you keep your work organized and separate, just like I've done on numbers 1 and number 2. Notice how I've kept the probabilities of each individual thing happening. I've kept them separate from one another, and I've also kind of kept them close by one another. So I know that I'm keeping all my probabilities in a line here, and I'm going to just take those and I'm going to multiply them, all right? All right, let's move on. I've got 2 more problems for you, and then we'll see how you do with this lesson. So the next problem, probability a coin is on tails 3 times. So this time, guys, I've got 3 things happening. Previous problems we had 2, this time 3. Notice, guys, on the previous problems, I had 2 things I was multiplying because 2 things were happening. I've got 3 things happening now. So I'm going to be multiplying 3 things together. I'm going to do this one a couple of ways here. Let's go ahead and if you're taking notes in a notebook, guys, let's go ahead and divide this problem up because I want to show this in a couple of different ways of solving it. The first way over here, we're going to do this through the tree diagram method. All right, so with our tree diagram, the first time that I flip a coin, it's going to land on heads or tails. The second time I flip a coin, after I flip heads, I could flip heads or I could flip tails. Same thing, if I had flipped tails first, the next time I flip a coin, it could be on heads or it could be on tails. Now a key with this problem, guys, we flipped a coin 3 times. This is 2 rows, so I need 1 more row. So if I were to flip a coin a 3rd time, I could have gone heads, heads, and then the 3rd time could have been heads or tails. Same thing with, I might have gone heads, tails, and then the 3rd time could have then been heads or tails. And you probably kind of caught on to our pattern here that we've continued. So I'm going to continue that pattern out for the rest of my tree diagram. I'm just going to branch a head or tails off of each of my options. And this would be very simple, guys, if it was a 2-part question. Okay, outcomes. How many outcomes are there? Well, count them up. 1, 2, 3, 4, 5, 6, 7, 8. There's going to be 8 outcomes again. 8 outcomes. Now, my question said probability a coin is on tails 3 times. Well, nothing in this chart satisfies that because I want tails all 3 times. And it starts with a heads. So none of these options satisfy tails 3 times. So let's come over to the right side. Tails, heads, Well, that doesn't work because I'm already into a heads. Tails, tails, head. Nope. Tails, tails, tails. So there's only one outcome that shows tails 3 times. There is nowhere else on this tree diagram where I see tails 3 times in a row. Where I see tails in row 1, 2, and 3. So my probability is going to be how many times it happens. It happened 1 time over however many total outcomes there are. And there's 8 total outcomes. So 1 over 8. We could also, guys, do this through the, and we'll just call this one right now the multiplication method. So if I have the multiplication method here, this time I want to break down my different probabilities. So I want tails. Each time I want tails. So the probability of tails, the first time is going to be 1/2. Probability of tails, the second time, 1/2. Probability of tails, the third time, 1/2. And we're doing the same thing with these fractions, guys, that we did on the last problem as well. I'm just going to come through here, and I'm going to multiply every one of these fractions together. Remember, multiply fractions, you multiply straight across. So 1 times 1 times 1. 1. Denominator. 2 times 2 is 4. 4 times 2 is 8. So 1 over 8. So notice, guys, both methods, same answer. Tree diagram, multiplication method. Same thing for both. Now, the last thing I want to do on this one is I want to find what is my probability. So 1 divided by 8 is equal to 0.125. I move the decimal 2 spots to the right, 12.5%. And there you have it. There is your probability of flipping a coin and landing on tails 3 times. Last question, number 4. Might be a good idea to go ahead and pause the video, write this one down, and then maybe unpause it once you've got it wrote. For number 4, it says Landon, Claire, Cece, Cole, and Logan were finalists for some St. Louis Cardinal tickets. I miss seeing you guys. I had to use a couple of you in this problem. I'll have to use the rest of you guys in some future problems here. So 2 names were drawn. So those 5 names were put in a hat, and 2 names were drawn because there was only 2 tickets available. What is the probability that Logan is one of the names that is pulled out? So notice there's 2 tickets that are pulled. Doesn't matter if Logan's the first ticket or if Logan's the second ticket. I just want his name to come out of the hat. Another way of solving these types of problems, guys, if you remember from our last video, we had the tree diagram, we had the chart, we also had the organized list. Let's try solving this problem by using an organized list. All right, so if I were to do an organized list, let's say Landon was the first ticket pulled out. So I've got Landon. Wow, this was not a good one to use because all of you guys are L's and C's. If Landon was the first ticket pulled out, it could be Landon and Claire. It could be Landon and Cece. It could be Landon and Cole, or it could be Landon and Logan. Now, even though, guys, I want the probability of Logan as one of my names, and I've already seen Logan's name pop up, I'm going to finish this organized list before I start looking for any of those. All right. What if Claire were to win? Maybe Claire was the first ticket that was pulled. So I have Claire and Landon. I have Claire and Cece. Let's see, we have Claire and Cole. Maybe those two are pulled together. Or maybe we had Claire and Logan. So maybe that was my combination of the two names that were pulled. Maybe Cece was the first name that was pulled out. And hopefully you're kind of catching on, guys, to where we're going here. So maybe it was Cece and Landon. Those were the two names pulled out of the hat. Maybe it was Cece and Claire. Maybe it was Cece and Cole. Or maybe it was Cece and Logan. Now, guys, something I want you to take note in. Notice we have Cece and Landon here. I've also got over here Landon and Cece. We have to include both of those, and the reason we do is because Cece's pulled first here, Landon's pulled first here. So the orders are different, so I do need to show both options when we're making this organized list. All right, continuing on with our list, now maybe Cole's name was drawn first. Well, we could have had Cole and Landon. We could have had Cole and Claire. Maybe it was Cole and Cece. Or maybe it was Cole and Logan. All right, and last but not least, maybe Logan's name was pulled first out of the hat. So Logan and Landon. Logan and Claire. Logan and Cece. Or maybe Logan and Cole. All right, so there is every single possible option with each one of our names listed first, and then all the remaining names following, maybe paired up with them. My question wants to know, what is the probability Logan's name is one of them pulled out? It doesn't matter, again, if it's first or second. I just need his name to be pulled out. So I'm going to go through. Well, here I see a Logan. 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 And then all of these options also have Logan. Guys, the way we find this probability is very similar. Just like on number 3 up top here, notice only one of my options satisfied this, so 1 was my numerator. So I'm going to count up how many of them made this true. 1, 2, 3, 4, 5, 6, 7, 8. So there were 8 different scenarios where Logan's name was pulled out, and that's what I want. How many total outcomes were there? Well, I can go through all of these and count them all up. So if there should have been 20 different outcomes. So there's going to be my fraction, 8 over 20. So just another way of solving these. If you didn't want to do the organized list, multiplication, tree diagram, there's different ways of going about this. I do think the list, though, however, was the best option for this problem. Last but not least, we find the percentage. So 8 divided by 20 is going to give me 0.4. I move that decimal 2 spots to the right. My percentage is going to be 40%. Guys, I hope you enjoyed the video. I hope you learned something in it. Hopefully you got all the notes down. Let me know if you have any questions over any of this material here today. All right? Thanks, guys.